Hello, everybody. Welcome to another edition of the Thoughtworks Technology Podcast. My name is Ken Mugrage. I'm one of your regular hosts. Had a little bit of a special edition this time. I'm at the Microsoft Ignite show. So we're recording this here in late November and was lucky enough to coincide with the schedules of a couple Thoughtworkers I think you'll find interesting. So today we're going to talk about some legacy modernization meets generative AI. My guest today, Tom Coggrave. Tom, you want to introduce yourself?
Yep. Hi, folks. My name's Tom Coggrave. I'm a technologist here at Thoughtworks, where I've been looking into how we can speed up the way in which we do modernization for our clients, and particularly looking into mainframe modernization of late.
Great, thanks. And Shodhan, Sheth, you want to introduce yourself, please?
Yeah, so I also am a technologist at Thoughtworks and play a similar role to Tom, and also focus on all things legacy modernization.
Great. So, one of the common jokes here at any large event is, don't play a drinking game around the word AI or the phrase AI because you won't survive. And so we know everybody was flooded with AI, but you all are doing some really interesting hands-on practical work that's actually been going on for quite some time now. So, can we say, for understanding the shift, how is generative AI helping you comprehend these complex, long-standing code bases for modernization?
I guess when you think about an existing kind of legacy code base, we're talking about something that's maybe 20, 30, 40 years old, likely kind of in the kind of many millions of lines of code. And so one of the problems with that is, I guess, the amount of time it takes humans or individuals to actually kind of get through that code, read through it, understand it, build a mental model in their head, and then be able to then explain that back onto other people to work out what to do about the problem is huge, right? Like that takes years. I mean, we've worked at organizations in the past where they measure the amount of time it takes for a new mainframe developer to get onboarded as around sort of 5 to 10 years before they really become truly effective across the whole code base. When we think about this new technology that's come in, generative AI is excellent at, it's not all powerful, but it's very good at kind of being able to kind of elaborate and summarize and explain documents, large amounts of text. And what is a code base? It's not that. It's a more of a structured kind of set of documents, but in effect it is documents with text inside it. And so that's where we're seeing kind of that's how we're seeing generative AI being able to help with comprehending these complex long-standing code bases, is through being able to kind of explain it to humans and summarize the key facts and key parts of it to humans at a much faster pace than previously has been able.
How did you do it before now?
Yeah, so I think in these, in the legacy modernization has been a long-standing problem, and there are many solutions pre-GenAI, but in our experience, they tend to be fairly mechanical, and they don't help with the issue around making it human scale. And I use that phrase without it being a stunt phrase, so I'll try to explain it. When you're looking at anything beyond, 1,000, 2,000 lines of code, it doesn't fit your brain, right? It becomes a non-human scale. Machines are really good at it. Humans are not good at sort of keeping that in their head. And so these reverse engineering tools or comprehension tools that existed weren't really solving that problem. So you ask one of these reverse engineering tools about, hey, explain to me how this business process works, and it'll give you a 200 or to 500 to 1,000 node flowchart. That's not something humans can sort of consume because you sort of get lost you can't remember those many things at the same time. And so I think one of the things that has changed with GenAI is it can sort of abstract it up. And I think that's one of the key benefits of using technology. So it gives you a human scale answer, and then you can sort of dig deeper, right? So it could give you an answer that's maybe enough to just give you a high level perspective of how that business process is working. And then you can sort of query further. And I think that's how humans work in terms of understanding large pieces. You first get a high level answer, then you dig into different parts, whatever parts you might be interested in. So there were tools before this, but I think the efficacy was not great. And I think that's what's changed now.
So do people just, fire up their OpenAI or Google tools? Or, what have we done to help you with this process?
So yeah, when we first started, that was actually the approach that we took, right? A lot of people in the industry, I think, were seeing a similar sort of thing to this. And so there was a lot of kind of excitement around, firing up ChatGPT, pasting in chunks, like chunks or files worth of code, and sort of seeing what it could help with. And so some of the early kind of like Intel tooling that we explored used this approach. It was kind of like a relatively, it was more to do with prompt engineering, about tuning that prompt to be able to get just the right amount of information out of the piece of code that we were looking at, right? But since then, we kind of have come to recognize, I guess, over the course of the last 18 months, so we've recognized some of the limitations that you run into on that with that approach, right? Code isn't, not everything to do with understanding a given piece of code is in the same file as that piece of code, right? Like you have dependencies, you have, the data schemas tend to live elsewhere. And so to be able to understand any one element of code, you have to be able to kind of look around that as well. And also, unlike a good essay, right, where you have a beginning, middle, and end, code isn't necessarily organized in that way. There's a different kind of structure and flow to a document of code, and you have to be aware of that when you're reading through it, so that you don't kind of like correlate things together that aren't related. And so we kind of recognize these structural challenges or these challenges that can only be dealt with by thinking about the structure and nature of code, and then started expanding the tooling that we were looking at to be able to take advantage of that, using things like parsers and parsers and kind of dependency graphs to be able to power the kind of the understanding of that piece of code, or the explanation of that piece of code a bit better with kind of related information, and be able to walk through it more easily.
As Tom was saying, we went through lots of different experiments to figure out the right sort of answer for this problem. The problem being, how do I understand a large legacy system? And one, I guess, insight we had whilst we were going through those experiments, some of them not successful as well, is the trick is to give the LLM the right context, right? And in a large code base, getting the right context is a hard problem, right? Somebody uses this analogy like that it's like an open book test. If you know where the answer is, it becomes a much simpler problem. If you don't know where the answer is, then the book doesn't help. And legacy systems are not a book because they're not that well written. But I'm sure you can understand the analogy that LLMs need to be given the right context for them to generate the right answer. And so that's where our engineering is focused at. Like all the engineering is focused on how do we get the right context for the question from the user.
Yeah, it's all been about optimizing to get just the right thing because of the context window limitations as well.
So I should have mentioned it at the top, but y'all are 2 of 3 authors of a fairly large article on this, which we'll link in the comments so people can read it. But one of the things you talk about there is that the challenges in legacy modernization. We've already touched on them a little bit, but from an organizational perspective, what are the kinds of challenges that you see people that generative AI specifically helps mitigate?
I think at the highest level, we sort of allude at the cost time value equation of legacy modernization, right? And like I always feel there was a time where we used to talk about stuff like, hey, that's rocket science, or it's not rocket science. And I think there's something that our industry needs to do when it's easier to launch rockets in space than to modernize legacy systems, right? So the cost time value equation of legacy modernization sort of is alluding into that, like how much effort is it to modernize legacy systems versus some other things happening in the world. And I guess primarily what we've one of the hypotheses we are applying is a lot of the cost time is also because of the cost of delay of understanding legacy systems. Because one characteristic or many of the characteristics of legacy systems are around the fact that documentation is stale or absent. There are no good safety nets around it. The SMEs around it have either disappeared, moved on, or are just not there. And that adds a lot of cost of delay to that modernization program. So that's one element of it. The other element of it is now addressed by a lot of the forward engineering GenAI tools, so coding assistants and the like, which is the legacy system is 30, 40, 50 years of investment of an organization. So it's quite a bit of quanta, right? And the expectation is to reproduce it in months or years. And it's just by nature, it just takes time to replicate something that you've been working on 30, 40, 50 years, right? So I think what we're trying to do is figure out the right pockets where GenAI can impact the cost time value equation of these legacy modernization programs. And code comprehension is definitely one area where we've found a lot of success. Coding assistance is another area that I think we've all as an industry seen some success. And it feels like this is still the tip of the iceberg. There's more areas to explore and see how we can make that impact better.
So you touched about years and decades there. I know some of the systems I've worked on, we have no idea why things were even in there. I mean, not only what, but what was the purpose or whatever. In your article, you actually talk about like, I don't think you use these terms, but backporting and getting the requirements from the code, like somehow looking at the code and trying to understand what is this trying to do? What's that process? What's that look like? And what are the benefits to doing that?
So what I guess, what is the purpose or what's the process of modernization, right? Like modernization is there to typically replace or refresh a set of technology that you can no longer maintain or no longer is fit for purpose, isn't allowing you to change at the pace that you need to, right? However, it still is performing a vital, unless it's gone very wrong, it's typically performing a vital function for your business, right? And so that function still needs to, or at least parts of that function will still need to continue in the new modernized world. And so when we're talking about kind of modernization, one of the things that we need to do is get the requirements, or get the understanding as to what the code is doing or what the system is doing. And so using generative AI, we're seeing that we can speed that process up using, I guess, generative AI. So the process itself looks like, I think what we were describing earlier, like using the generative AI like large language models and abstract syntax trees and parsers and kind of dependency graphs to be able to walk through that, provide exactly the right context to that LLM and prompt it to produce descriptions about kind of what the code is doing, which we then can treat as requirements that we decide whether to take forwards or not, right? Another hallmark of legacy systems is that they have, the processes that are in place are there because they haven't changed, I guess, they haven't been updated as the business has changed over time. And so people may still be, or the employees of the company may still be following, processes that are kind of out of date or unnecessarily complex. And so for us, one of the reasons why we like to have a human kind of in that loop, or a modernization process that involves kind of re-engineering and re-architecting, reimagining what the future looks like, is so that we can get rid of the cruft, the kind of the dead code of business processes, as well as the dead code itself when we're going forward. So yeah, the benefit there is that using generative AI, obviously it's going to be much less time, hopefully much faster to kind of get those requirements out. But then you still need that human in the loop to kind of get rid of what's not needed as well.
So you touch on something that I think is important there, the human in the loop. One of the things that I know with different ThoughtWorks topics, whenever we talk about generative AI or AI or machine learning or what have you, is the necessity of having someone that knows what good looks like. How does that work, or is that a factor here? Because, I could just write a program, right, that translates a thing. But what is that human in the loop? How do you use, whether it be tools or processes or, sticks or carrots, how do you get the human in the loop that knows what good looks like to participate?
We are talking about two maybe different areas of application for AI, and maybe the answer is different for those two. In the area that we just talked about in terms of like comprehension, it's almost an easier answer because the consumer is a human. I think there's less of a question of how to get them in the loop because they're at one side of the equation, right? One side of the equation is the legacy system, and then there's some technology in between. The other side of the equation, the consumer is the human. And so we're not saying like these technologies give you 100% accurate answers. There's also some skill involved in terms of crafting the prompt, etc. But because you can almost interrogate the technology about your legacy system, the human is sort of constantly involved in that process. When we talk about translation, I think there the human in the loop factor is different. And to be honest, we don't know what is the right answer, or at least I personally don't know what is the right answer. I think that area requires more experimentation because we come from a more deterministic approach in that sense, right? As people who are big fans of continuous delivery, like what we like to do is like, okay, I've written the code and committed code. It should now automatically move towards production. That doesn't look like a feasible or viable process based on where these technologies are today. And I think there's more experimentation and more sort of trialing needed to figure out what is the right process, so that there's enough confidence in the output, right? Like there's probably a threshold after which, assuming it's not a system that has like life impact, right? Assuming it's not that sort of system, that there's you can reach a threshold of confidence where you're like, okay, maybe this can work in more automated fashion. But I don't think that pipeline exists today, or that process exists today, or we're not aware of a very successful version of that.
One of the things that we also struggle with, I think, as technologists, and I guess I'm going to be a little careful here because we like to refer to business users. And I have to admit, I have a very personal bias here where whether you're writing automated tests or you're a developer or you're selling the system, it's all part of the business. But that said, most of what we're talking about is from a technical, like, what is this function doing, et cetera. But one of the things we hear from people in the quote unquote business is, well, modernization, you're just taking functionality that I have and rewriting it in a different language. Is this helping with building? What are the high level explanations that we can share with the non-technical stakeholders, put it that way, during a modernization project? Does this help with that at all?
When you're kicking off a kind of a modernization program, right? We talked a little bit about some of the challenges that businesses are trying to overcome by changing that technology stack. But even within that modernization program, there tend to be a priority that you can apply to aspects of the system. So choose the order in which you might want to modernize, or choose the things to understand at a high level what are the things involved in that system, so that you can make decisions about whether you need to necessarily reimagine or re-engineer those functions, or whether you can potentially look to now buy something off the shelf to support them, right? And so it's quite hard if we're talking at a level of, say, like, stories or even epics in terms of like the requirements you've extracted from that existing code. It's very hard to abstract sufficiently to be able to compare whether what you've got in that code is fulfilled by an existing system, right? So, I mean, taking a very, very basic example, if we talk about like identity systems, right? Back in the old day, you had to roll your own. A lot of legacy systems will have their own identity and access management sort of capabilities built into them. And so nowadays, you don't typically do that, right? Like, it's a huge risk to run your own one of those. Most people these days will be buying something off the shelf or licensing a SaaS product to do that. And so it's that kind of decision about being able to replace those functions, those capabilities of the existing system. You need to be able to abstract to a sufficient level to know that there's something out there in the industry to do that for you. And so it's that ability to kind of abstract from low level detail to something higher level that kind of enterprise architects and kind of business users can discuss about, allows you to make those decisions. And so generative AI, as we were saying before, is quite good at summarization, it's quite good at explanation. And so taking that capability that GenAI has to be able to abstract those low level details up into something that's kind of something that allows you to kind of, I guess, compare and contrast existing solutions or even prioritize amongst those things as you go forwards is super useful. It's very helpful, and it allows you to kind of, I guess, speak at a level where a business person would understand that this is a function that your organization does or doesn't need to do. And so that we find super helpful in our modernization programs, and we're using kind of generative AI to make that faster as well.
Yeah, so it's interesting because you mentioned identity and so forth, but I think anybody that's involved with one of these projects knows there's a lot of code in there that simply isn't doing anything anymore. It might just not be executed. They've replaced it with something else. So there's just dead code. It might be duplicate. It might be just unused. Can this help identify some of that? Have you been able to pull out some of the cruft in this way by understanding the system better?
We run early experiment where we've seen a little bit of success, but I think we need to see more to sort of call success. What I would say, the thing that struck us was syntactic duplication has been around for a while. And so it's easy to spot that, these two statements are exactly these two statements here. And, there are lots of static analysis that do that. But with legacy systems, again, because code has been authored at very different parts of time by very different teams, the duplication is more semantic in nature. So it's not easy to spot. And one sort of lead we have, I would say maybe not success, is by doing some bottom-up clustering of code, we've sort of been able to spot in one occasion common functionality across legacy code bases. And so that would be the notion of semantic duplication. I think we still need to apply it at more places to see if it's an approach that scales, or was it just that one scenario where we were able to spot it. But I think that's one lead we have. Right now, the other perspective being is we've not folded in observability into this tool that we are building. So it's based on the notion of code. And so if you were to fold in observability, if you were to mix and match how the code is structured and what is being used when through your observability data, then it possibly gives you more data points on figuring out this part of the system hasn't been used for the last 2 years or something of that sort. And that's something that a lot of people ask us. So it is something that I guess is on our roadmap to look at, but we've not looked at it right now.
How much is of this whole topic? How much of this is still experimentation, and how much is this the stuff that you can go do today?
We sort of categorize what the tool does in terms of like these different scenarios that a user or persona might be using. So their scenarios are like, hey, I want to understand how this feature works, or I want to understand how many validations and business rules there are in this part of the process. So that's that's in production for multiple customers that we worked with. So we would say that's going on pretty well. So questions that are of the nature of how and where. So, hey, can you tell me where is this implemented, etc. Those things are pretty good. There are what questions, right? Like what business capabilities does this large legacy system serve? We would say that's more experimental in terms of how we're sort of approaching it, and we want to see more proof points of success before saying, yes, this is a good problem solution fit. And then there's areas around auto-generated documentation. I think a lot of the industry has seen a lot of success with that. So I would say those three main buckets would be the main ones. So I think the what type of questions, like tell me what business capabilities does this large system serve, I would say is still experimental from our perspective. And then a lot of the how and where questions, like explain to me how this works, or tell me where this piece of functionality is implemented, or tell me what is the impact of changing this part of the system. Those things are in production. So we would say
Yeah, I asked that because, one of the things we hear a lot is like, hey, we've done a lot of good experiments with AI, but none of it's in production. So in this case, you think 2 out of 3 buckets are ready to go. And yeah. So then shifting gears a little bit, modernization isn't always just about, hey, I had a monolith and now I need microservices or whatever. There's also completely different paradigms now, right? I mean, we have software-defined vehicles where, some of the code's like driving down the motorway, et cetera. How does this help with that, or does this help with that? When you have, you want the same thing, you need the person to know what their fuel economy is and when the gas tank is empty, and it's completely different paradigms. Does this help there at all?
I think this is one way we hope it will help. And again, we would say there's still a lot of experimentation to do. The common classic cliched example being the fact that the mainframe operating or development paradigm being very different than today's cloud native microservices Java development paradigm, right? And so translating between those two paradigms in I guess in our opinion has not yet been achieved. There are lots of code translation tools out there actually, and the common sort of view is it's COBOL to JOVOL, right? So you will see COBOL in the shape of a Java class, but it will have similar variable names that it had in COBOL. It would have similar method calls as they were there in COBOL, right? And that wouldn't be modernization, because you modernize it to decrease your cost of change. Now, if a new Java system is as difficult or more difficult to understand than the COBOL system, then you've not sort of achieved your goal. So there's lots of translation tools out there, but we are hoping with GenAI that translation can be higher quality, because one of the challenges is how do you translate procedural code to object-oriented code? How do you translate the variable names that were written 30 years ago that were more optimized for maybe storage or, the constraints of hardware at that environment to today's computing paradigm, which is completely different. So it's an area that we think there is some hope, but again, there's a lot more to do before we can say this is an area that this can help.
So just two more questions to close it out. And these are going to be pretty speculative, fair warning. And not necessarily just I know both of you live in the modernization world right now, but just in general, if you crystal ball, is generative AI the miracle that they would have us believe in the keynote we saw this week?
Predicting future is always hard. And we have seen, I guess there is precedent of multiple technologies being on the hype cycle and then not sort of doing as well as we thought. But overall, we feel we need to be cautiously optimistic. So a bit of caution to make sure you don't believe in everything that's being said. It definitely can't solve all the problems of the world. And so our focus is always on problem solution fitness. So find the problem that's a fit for this solution, rather than just trying to apply it at all places. I think there's still a place for traditional AI, right? Like all the other forms of AI that were there pre-GenAI. Again, one learning that we've had through development of this tool is actually GenAI works better when you pair it with these tried and tested other technologies, right? So a lot of this tool is abstract syntax trees, graphs. These are all technologies and approaches that have been there for 20, 30 years. And so we've married it with GenAI rather than just GenAI being the answer to everything. So I think we are definitely being cautiously optimistic, but and sort of investigating more avenues where we think it can help. But to be honest, time is the best future teller.
Somebody on a previous podcast said, we still need to know if else. Not everything's AI. Tom, what about you? What do you think about the future? Where's generative AI going to be effective or not? I know these are guesses, folks. I don't mean to put you on the spot, but I think your guesses are better than most people's facts. So
one area I'm particularly hopeful for, if not maybe not excited, I guess. But one thing I think is could be very powerful is, especially in the field of modernization, or like looking just a little bit further ahead in terms of modernization, is around the kind of the safety nets that we might want to have in place for that we need to get put in place to be able to do that modernization, right? So when you're taking some 40-year-old system and trying to move to a new modern architecture or a new modern kind of version of it, you need to make sure that where you are replacing a function that has been there for a long time, the pace at which you can do that is limited by the quality of the tests or the existence of tests, which aren't always there in these cases, right? So I think one of the areas that I'm excited or hopeful that we'll see is like how can generative AI help us get more safety around the existing systems to be able to not just describe what they do, but almost provide test cases for kind of how that works right now, so that we can then cross compare against in the future as well. That's definitely one area I'm super excited about. I guess I'm a little bit less, maybe a little bit less. I'm very excited by kind of like a lot of the experimentation that's going on around kind of like the creation of software. I guess the creation of software by kind of like generative AI agents or by all these sorts of things. But I think I should have saying there's going to be a necessary kind of set of framework or infrastructure that sits around these LLMs to be able to ensure the right context is given to the LLM at the time when we're generating code or when we're trying to create a system. And there is complexity in that. And I think, there's one level of complexity to be able to extract understanding out an existing system and, represent that in graphs or whatever. It's probably an extra couple of orders of magnitude harder to be able to retain that context as we're building out a new system. On the other side of that, like almost in reverse of the kind of the understanding and explanation side of things. So I'm excited about that. I think it's probably a little way off. Hopefully going to be proved wrong, but I think it's probably still a little way off at this point.
What are the key considerations and best practices, what that you recommend to secure, whether or not they're using Thoughtworks and our tools, frankly, or not, but for an organization that's wanting to leverage GenAI for legacy system, what are some concrete next steps they can do to try to help ensure success?
So I'll maybe repeat some of the stuff that I've already mentioned. So don't look at GenAI as the one-stop solution, the silver bullet. at least in our experiences, all production solutions are a combination of technology paradigms that are sort of married with GenAI. The other one I would say is focus on problem solution fitness and treat it as, if you're doing something new, treat it as an experiment. Be ready to pivot and learn from that experiment and try different approaches. And then the other thing, I guess, is that this is a different paradigm in terms of the determinism that we are used to. So it does take a while to start becoming comfortable with that. And there are some, I think, new skills that we will have to add to our prompt engineering is the most commonly talked about skill now. It takes some experience to figure out the right crafting of those prompts and the right way to sort of ask it a question, the right context to provide it. And so those are all things that organizations will have to learn with or without Thoughtworks if they want to survive in a GenAI world.
Tom, what do you think? What's your actionable advice there? It's okay if there's some overlap.
Yeah, no, I think I'd probably just build on a couple of things that Shodhan was sort of sharing there. One of the things that we that allowed us to get around that experimentation point that Shodhan was making. Like, I think the ability, the fact that we at Thoughtworks had internal access to some of these tools to be able to experiment and drive this stuff forwards was actually part of the reason we've made as much progress as we have, right? So I think a call out for organizations would be, how can you quickly put these tools safely into the hands of your teams, your employees, so that they can discover ways in which to, improve their processes, change the way in which they're doing things, hopefully for the best of the overall organization. So definitely one call out is to enable kind of access there. But I think the second one is building kind of what Shodhan was saying around like different approaches, right? One specific example that comes to my mind is around kind of, where previously developers have written kind of like, X unit tests to kind of like that to specify the behavior of the stuff. We can't expect that with generative AI, right? And so it's about shifting to like look at evaluation techniques, like for instance, like using kind of LLM as judges, kind of like one of the ones that's doing the rounds at the moment, to be able to validate or to be able to evaluate the quality of the output of some of these generative AI based systems. It's like that mindset shift of determinism to sort of how do you deal with non-determinism, but still get confidence in the system you're building is definitely a shift and definitely making certainly me feel uncomfortable, but getting through it.
Thank you both. I appreciate you taking the time, especially, you're here in Chicago for an event and got to head home to London. And very much thank you. And thank you to our listeners, and we'll see you next time.
Thanks, Ken, as well. Bye.
Thanks, Ken.